There is a chance that our universe contains objects that first emerged in the theory as something that existed in the far past of black holes, to now one that may potentially be the way black holes prefer to die, solving one of the biggest problems related to black holes. Hello everyone, today it's time that we talk about the black hole's mirror twin, the white hole. White holes are regions of space described by general relativity that can't be entered from outside. We are familiar with the idea of a black hole. In a black hole, there is a boundary called the event horizon, and if anything crosses that boundary from outside, it can't come out. However, in a white hole, it is completely opposite. There is also an event horizon in a white hole, but this time it is not a boundary from which we can't come out, rather it is a boundary to which we can't cross. Nothing can go inside of a white hole. Technically, if you can travel faster than the speed of light, you can go inside, but traveling faster than light is theoretically impossible. So effectively nothing can go inside a white hole's event horizon, as nothing can come out of a black hole's event horizon. Or in short, a black hole's event horizon is a boundary of no return, while a white hole's event horizon is a boundary of no entrance. Now that doesn't however mean that white holes are repulsive. A white hole has positive mass just like a black hole, they also attract matter toward them. However, inside a white hole's event horizon, space-time flows faster than the speed of light in the outward direction. So you need to travel faster than the speed of light to get inside a white hole's event horizon, which is impossible. In this sense, it seems as if black holes and white holes are somehow connected, like one is the exact opposite of the other. And indeed, they both come from the same mathematics of general relativity. A white hole is just a time-reversed version of a black hole. The first glimpse of a white hole has come from studying an eternal black hole. An eternal black hole is one that has existed and will exist for eternity. It is the simplest kind of black hole you can get. It does not have any charge or spin and only has mass. And this type of black hole do not really exist. It only appears in the mathematics of the theory. However, subsequent work led to the discovery that this type of black hole would have a white hole region in its past, and it would be just like a black hole, but with time going in the opposite direction. To understand this, we need to take help from the Penrose diagram. These are coordinates that help us visualize what's happening in space and time. Here, space is represented horizontally and time is represented vertically. The coordinates has been chosen so that light rays always travel at an angle of 45 degrees to the vertical. And the borders of the diagram shows infinitely far space and time. The event horizon of a black hole exists infinitely far in time for an outside observer because time literally freezes at the event horizon because of extensive time dilation relative to an outside observer. And since the borders of the diagram represent infinitely far space-time, it can be considered the event horizon of a black hole. Now, since an eternal black hole must have existed in the past, we get this region of space, a time-reflected version of the black hole, or a white hole. So from this diagram, we can see that an eternal black hole has two singularities. One in the infinite future, the singularity of a black hole, and second in the infinite past, the singularity of a white hole, of a faraway observer. And the theory says that if we enter such a black hole, and if we can travel faster than the speed of light, we would not be crushed in the singularity, but will be transported from the black hole to the white hole through what scientists used to call a wormhole. Yes, I can understand at this point we have so many holes in the theories, but at least these aren't any loopholes. Okay, so wormholes. Wormholes are actually kind of tunnels between different regions of space-time. These act as bridges that connect different regions that may be a lot far apart in both space and time. And these are one of the favorite ways to travel faster than the speed of light and travel back in time in popular science fiction. This white hole that we get from the eternal black hole, however, can't be observed by a faraway outside observer because light rays coming out of it would take an infinite amount of time to reach that outside observer. Plus, such an eternal black hole do not really exist. They only exist in the ideal situations of the mathematics of general relativity. But still it helps us understand how a white hole, if it really exists, would function in real life. Now, black holes that really exist in our universe form by the stellar collapse of massive stars, so they are not eternal. Hence, they do not incorporate a corresponding white hole region in their past. Because before the black hole in the past, there was a star. But black holes being connected with white holes through wormhole has not truly been ruled out yet, so this can be true. Well, all of this is very theoretical. Is there any real mechanism by which a white hole can form? Well, we know that black holes really do exist, but there is no currently accepted way by which a white hole can form. There are some ideas which I will tell you about in a minute, but no convincing observation has ever been made that tells us about that white holes really do exist. Forming a white hole is a process by which the entropy of the universe decreases. And many of you would be familiar with the second law of thermodynamics, which says that entropy must only increase. Entropy measures the disorder in a system. So what this law is saying is that the universe gets messier over time, and forming a white hole requires a very ordered structure, which then gets messier over time. Now, this entropy must only increase law is not actually a law in the usual sense. Like, entropy is a statistical phenomenon. For example, if you take cold water and put it on warm water, they will get mixed and the entropy would increase. However, this only happens because there are so many ways by which hot water can get mixed with cold water and very few in which all of the molecules of water interact in just the right way so that they remain unmixed. Because theoretically it is not impossible for the warm water and the cold water to remain unmixed. Even cold water getting more colder and warm water getting more warmer is theoretically not impossible. They can happen. But the chance of this happening over all of the things that can happen is highly unrealistic. That's why we say that entropy only increases, because in a high enough system, it is highly unlikely, highly unrealistic that it will ever go down. But that does not mean that it cannot go down. So entropy can go down, but it's highly unlikely that it will. For example, Big Bang was such an event where the entropy of the universe was very lower. And we think that it may be the result of an entropy dip, because given enough time, anything can statistically happen, and the Big Bang was such an event. Now, the behavior that we see of the Big Bang and the white hole looks very similar. Like, both of them start from a lower entropy state and then gets messier over time. Everything gets thrown out of a white hole looks very similar to a Big Bang. This leaves many wondering, was the Big Bang a white hole? This is an awesome thought to have, but not necessarily true. It can be true, but there is no significant evidence that both of these are the same thing. It is important to understand that Big Bang is something that we know has happened, but white holes are purely hypothetical at this stage. In the Big Bang, every point of the observable universe started to expand, but in the white hole, it doesn't appear so. So they are not purely similar. Like, they have some things that match, but that doesn't mean that they are the same thing. Now, at last, there is an interesting idea related to white holes that can potentially solve the black hole information paradox, plus can also be experimentally verified. First, what's the black hole information paradox? Okay, so as we know that anything that falls inside the event horizon of a black hole cannot come out. It is forever lost to the outside universe. However, in 1974, Stephen Hawking came up with an idea now known as the Hawking radiation, which describes a mechanism by which black holes can radiate energy. The amount of energy radiated depends upon the size of the event horizon of the black hole, and importantly, nothing else. That implies black holes can just vanish into nothingness. The point of concern is that the information of what has fallen inside the black hole has been lost, because the energy that's been radiated gives us no account of what the black hole that has existed constituted of, like what the matter has fallen inside it. The information regarding whatever has fallen inside the black hole appears to be lost. The information of everything that has fallen inside the black hole appears to be destroyed, which directly contradicts quantum mechanics, which says information must never be destroyed. Now, there is an idea that comes from the loop quantum gravity that black holes die by turning into white holes and spewing out all of the matter that has been inside the black hole outwards. The way it will work out is that at extremely small length scales, quantum effect starts to take over and stops the collapsing star to shrink to zero size. Instead, there occurs a rebound. But because of the ginormous gravity of the situation, time has been slowed down relative to an outside observer. So, to an outside observer, this process seems to take a long time, and eventually, when the time comes, the black hole rebounds as a white hole, ejecting all the matter outwards, solving the information paradox. And it might be the case that some of the supernovas or gamma reversed or FRBs that we have observed are actually these white holes in action. However, these white holes aren't continuous, they are spontaneous. So when all of the matter is ejected outwards, they die. So they can't be observed indefinitely. They can only be observed when they are doing this thing, and after that they are just gone. White holes are hypothetical objects. There is no physical accepted process by which they can form. But there was a time when black holes were in this position too. And we know that the universe has always been ahead of us, and it has always surprised us with things that we thought would be impossible. Black holes are just an example for that. And at last,